sorting algorithms are used regularly in computer science and programming. In this course, you will learn how the most popular sorting algorithms work using diagrams and code.
It's coding time with Coding Cleverly. But this time, we're on a different channel. That's right, Coding Cleverly is being featured by freeCodeCamp. This video will be about some of the different sorting algorithms that you can apply to almost any programming language. The language focused in this video will be C++. However, like I said, you can apply the concepts to any other languages of your choice, like Java, Python, C, and so on. You would at least need to know the fundamental core concepts of programming, especially the basic programming constructs like sequence selection and iteration, to understand this video. Also, make sure to check out my channel Coding Cleverly, where I've covered almost every concept from programming fundamentals to object-oriented programming, all the way to data structures and algorithms and beyond. Okay, so let's start by writing a simple algorithm for sorting an array. So first of all, let's include our IO stream, and I encourage you to type along with me to get the maximum practice. So hash include IO stream, and then we have our namespace standard, and then we have our integer main, and we also have our return 0 right here. So we're going to start off with a very simple algorithm, and we're going to look at its visual implementation. So suppose we have an array of 4 elements, and that's the 4 size. We have 2, 3, 1, and 5. And basically this is an array which is basically indexed having values from 0 all the way to 3. So our job is to sort this in ascending order. We know that this is not in ascending order. So we're going to use a very simple algorithm, and I'm going to create actually the implementation here. So then after that, we go back to our code editor and we're going to type along, and it's just going to make much more sense. So suppose we have 2 variables, and we're going to have one variable which is going to be enlisted on the top. So we're going to have that as I. So that is going to be the first one, which is 0 location. And then we have j, which is going to be the second one, which is going to be I plus 1. So right after the I is going to be the j. And we're going to apply actually a nested for loop. So first for loop is going to have some condition. So after inside, there's going to be a condition that says j is less than I. So over here, what it means is that the array of that j, the value of that j is less than the value of that I. Now that's what I meant by array sub j and less than array sub I. So the value of j less than the I value. This is our condition that's going to be inside of our nested for loop, the internal one. And this is the condition. If it's true, we're going to create a temporary variable, and we're going to store the value of I. So whatever's in I, so in this case 2 is in it, so 2 is going to be stored in temp. So then we're going to swap it using a famous swapping methodology. I is equal to j, and j is equal to temp variable. So whatever the temp value was, it actually was I's value was 2, so that's going to be in j. So actually we just implemented a swap methodology here. So right after that, we're going to check in this condition. So in this case, we have 2 and 3. So value of 3 is actually greater than the value of 2. So in this case, the condition won't be true and it won't execute. So this is just going to skip the value, and we're just going to make our j now increment to the next portion. So we're going to skip this. So I just cross this out, and now I go and put this next pointer over here in j. So now I and j. Now you can see that j's value is less. Now we have 1 and we have comparing with 2. So 1 is less than 2. So this condition is now true. You could see that 1 and 2 are going to be located, talking about the values. And now that the condition is going to be satisfying here, so we're going to look over here that temp is equal to I, and then we have the value which is I. So what is I? 2. So that's going to be in that temp variable. I is equal to j. Now j is actually 1. So I is equal to 1. So we're going to have here I is equal to the value 1. Now after this, we have j. So j is equal to now the value of temp. Now temp value was actually 2. So now you can see that this swapped value. So we have I, which is now 1 except for 2. Now 2, and now over here in the j position, instead of 1, now we have the value of 2. Now you can see that swapped out, and now j's value is going to be incremented. So you can see that the index is now no longer going to be here, and now it's going to be in the fifth, actually the last one, which is where the 5th value is. And we're going to be checking again. We're going to say I and j. We'll say j is less than I. Well, No, it's not. J is greater than I. So now this portion of that nested for loop will be terminated. And what's going to happen now is that I is going to be incremented. So I plus plus, and we're going to have I now plus 1. So originally where J was, right? So now that's where I is going to be. And actually, what we see here is that J is always going to be I plus 1. Like what we mentioned before, this is our sorting algorithm process that we need. So it's just going to be side by side, or they're going to be adjacent to each other initially, and then after that they're just going to be incrementing. So just like J's position. So we have J over here, and we have I and J. So if I look over here, we have I, which is 3, and J, which is 2. Check the condition. Now that's true again. So what's going to happen is that J is less than I. That is true, and we're going to process this. Temp is equal to, now you could guess what's happening here. Now temp is equal to the value of I, which is 3 now. So 3 is going to be placed here. So there you go, 3. And then after that, we have I is equal to, now the value of J. J is actually 2. So we're just going to have 2 over here. I is equal to 2. And then the last one, which is J is equal to the value of temp. Temp was 3. So that places over here. So now we just basically swapped it again. So we have, instead of 3, we have 2 over here, and instead of 2, we have 3 over here. So you could see now that J is now going to be incremented again to the last one, and we can see I is just in the same exact position, and it's going to compare 2 and 5. Well, that condition is not satisfied for this condition, so it's just going to increment that process again, I and J. Now it's going to compare and say 3 and 5. Well, that condition is also not true for that while loop to be executed. So now we have this I and J in red, so you see that there's nothing to be changed. So we have actually our algorithm is working, and we see that 1, 2, 3, and 5. You can see 1, 2, 3, and 5. They are in ascending order, and that's how our algorithm was supposed to work. So this visual implementation of this algorithm helped us, and now we could map this into our code. So we're going to be right now typing, so I would encourage you to type along with me. So let's just get things started. Okay, so the thing here is that we're going to have to create an array, and I call it an array, and I suppose we want to have a size, so I could define something over here on the top. So I say hash define, and I say max, and I say that's the 100. All right, so this is the max value, so we just put max here. And what I could say here is that I could ask the user to enter a number n, and that will be the size, and it should be in between 0 to 100. So it's going to be input, and then it's going to be n. Now I need to define an n here, so I'm just going to say integer n. So this is the integer n. Now inputting values in an array. So inputting values in an array, we could do 4, and we say int I is equal to 0, I is less than n, and we say I plus plus, really simple. And then we have the rand function that's gonna put values randomly inside of each indices. So we could say array sub I, and we could say just the rand function, and that's it. So this is gonna give a number between 0 to the rand max, whatever the integer max is. So what we could put here is that we just have to include one more header file for the rand function. So it's called C standard library, and there you go. So C standard library is done. Now we have values inside of this. Let's output our array. So outputting the unsorted array. So unsorted array, we could just basically say for int I is equal to 0, I is less than n, and then we have I plus plus, and then we say console output array sub I, and we put this space, and hopefully we'll get an array. Just put an end line right here at the end, and now I save my code, so I'm going to run it using my G++ compiler. So over here I'm going to be writing G++, my name, which is part 1, and we have CPP, and hopefully it's going to be compiled. Now we could just say A to run it, enter a number n. So basically I could say 10. Now it's going to give me 10 random numbers for my array. So it has 41, this, and this, and all the way to 10. So you can see that these are 10. Let's run this one more time. And now I'm going to input 20. Now it's supposed to give me 20 random integers. So now there you go. How about having 50. Now 50 random integers. Now you got my point over here. It's creating a randomized array and it's putting some random values. But you could see over here that these are not sorted in any kind of order. They're not in ascending, no, they are in descending. And now that's our job to put that. So we can see 41 and you can see that this is a number that's greater, but then after that you can see a smaller number. And what is this even meaning? So we need a properly managed array. So let's create a properly managed array. So what we could do here is right after this, let's create a sorting algorithm. So sorting an array. So how are we going to sort this array? First of all, let's go and open a for loop. So we could say 4 into I is equal to 0, I is less than n, and then we say I plus plus, and then right after this we could put another input array. So we could say this another loop that's going to be nested inside of the beginning one, so it's going to be j. But this is careful, this is the next value after the array, and I'll tell you what's the reason behind this. So j less than n, and we say j plus plus, and now inside of this is basically our concept that's going to be applying with array sub j is less than array sub I. Now what does this mean? I'll tell you all of this. So suppose we have an array and this says that if array sub j is less than array sub, because look at this. So this is an array and you can see that it's in order. So you can see that this is the I value which is starting from 0, and this is the j which is starting, which is greater than I when 1 times. So you'd say that j is this and this is I. Now if I had a randomized array, so let's say I had 5 over here, so you could see that this is not in ascending. It's basically 10 and then it's 5. Why is 5 over here? Something bigger should be appearing. So the condition here is that array sub j is less than array sub I. So meaning if array sub j, which is this, is less than array sub I, and that is the case. Now what we want to do, we want to swap the values. So what we could do by swapping the values, so 5 could be over here and the original value 10 should be placed over here. How do we do this? Because 5, 10, 30 and 40 will be then sorted, and the thing is that we're going to have to create an input integer temporary something. So we're going to put that and assign that with I. Now once we have that assigned with I, now what we could do here is that we could change array sub I and we could say to that to array sub j. So we're assigning array sub i's value with array sub j's value, and now we can have array sub j's value and we could put that as temp value. So this is gonna improvise our array in a sorted fashion, and it's going to be in ascending order. ASCENDING ORDER. So this is going to be in ascending order. So it's going to check, and then after that it's going to do this. It's going to go into our next iteration, which is going to be I is equal to 1. So plus plus increments to this, so it's going to be this value, and then it's going to be checking with this value, and it's going to see if it's the case that it's not right, it's going to swap it, else it's just going to do this next iteration until the array is done examining. So once it's done, you could just break out the loop, and once you're you're free. So once you're free, you return the 0. So this is going to give me my array in ascending order. But now we don't have anything displaying it. So let's display this array. So I'm just going to write comment sorting the array. Now we're going to display so let's just say the sorted array. So displaying the sorted array, we just do a basic for loop. I is equal to 0, and we can say I less than n, and then we say I plus plus, and then over here, which we could add is basically console output, and we say array sub I, and then we say this, and now let's just put an end line right here. Now let's run the code. So basically go back to our G++ compiler, and we're gonna be running our code. But first of all, let's compile it, and I'm just gonna give a -o flag to indicate that this is a new executable, and I'm just gonna call it run. So I'm gonna hit the compiling button. Compilation is successful. Now we're just gonna run. So now you can see enter a number n. So enter a number n, meaning that let's just enter some random number, and it's gonna create an array with some randomized values in each indices. So let's have 20. Now these are 20 random numbers. You can see over here for 20, 41, and all of this, which is unsorted. It's just in random order, and then after that it sorts it, and you can see my sorting algorithm does the trick and sorts them in ascending order. That's pretty amazing. Okay, now let's do one other thing. For us to have a descending order fashion, one other thing I want to do here is that I want to tell that this is going to be the sorted. So I could just write a console output and I'd say sorted. So sorted, and right here displaying the sorted array. And the other thing that I want to do is I just want to show you how descending works. So this less than sign, which is array sub j less than array sub I, will just be turned into array sub j greater than array sub I. So if it's greater, then swap it. So that's basically descending order. So I'm just going to change this ascending to DESCENDING. So this is now going to be in descending order. So it's going to run again. So I'm just going to compile this basically, and then we're going to run it. And now let's have a value like 22. Now you have these values which are 41 and all of this in random order, and then after that you call the sorted, basically prompt it out on the terminal screen, and then after that you sort them in descending order fashion. And look how awesome that took. So that's it with this one, and now let's continue with the other sorting algorithms. So the next sorting algorithm is called the selection sort, one of the most common and most famous, well-known sorting algorithms in the world. So how we're going to implement this is basically first type along, and we're going to be explaining side by side, as well as going to give a brief explanation at the end. So just keep on typing along with me. So hash include, we're going to have input output stream, and then we're going to have using namespace standard, and then we also have integer main, and we also have the return 0. Now what we're going to do here is basically first we're going to create a swap function. So what I'm going to be implementing is basically a swap function. So void, and then we have swap, and then we have basically an array we're going to have, and it's going to be swapping. So I'm going to show you that it's going to have an x value and it's going to have a y value. So it's going to be implementing that famous swap function process that we've been doing. So what's going to be doing is basically integer temp is going to be having a sub x as the first value. So a sub x, so a sub x is going to be equal to a sub y. And then what I have is a sub y equals to the temp variable. So, and that's how we swap something. So suppose we have an array inside of it, and we just call it an array, and we're going to have some values to it. So let's say some random values. And what we want to do is basically we want to swap the process over here. If we have some random values, they're not matching, and we want to swap them, we could use a swap function like just we did in the basic algorithm in the beginning, what we did ascending order. So basically we're implementing selection sort. So we created our first function, which is swap. The second function that we're going to be doing is basically the selection sort. So how this is going to go is basically we're going to have a void, and we're going to call this as the selection sort, and it's going to have two input parameters. First one is going to be the array, and the second one is basically going to be the size of the array. Now inside of this is going to have the location index, which is 0. It's going to always start from 0, arrays start from 0, just that, and then after that it's going to loop through this. So it's going to be I less than n minus 1. We're going to loop to the last element. So n minus 1 is the last element, and then we're going to have to find the value that should be smaller than the value that we're specifying as I0, and it should be like swapping the function. So we're going to have to indicate one j over here. So it's going to be called, and we're going to use another function which is going to be called location of smallest, and don't worry, I'm going to be teaching what this is. So basically we're going to have a sub I, and we're going to have n minus 1. So we're just going to have three input parameters here. We're going to have the array passed in, and you know this is passed by reference, so it's always going to be the same array no matter where you're going. And then we have I, which is going to be the current location. It's always going to be incrementing, and it's going to be 0 over here. It's going to be changing, and over here is the ending point. So that's the last one, ending last element. So swap is going to be implemented here, and it's going to have three input parameters just like we did before. So it's going to have the array, which is small a, and then it's going to have the size of the I, and it's going to have this j. So basically I, which is going to be the index, so it's going to be the first element and the second element, and wants to swap them. So it's going to be implementing this swap function, and it's going to be incrementing I++ here. So this is how it's going to be doing. Now what we need here is the location of smallest function. So let's just make it right here. So what we're going to do here in the location of smallest is basically have a return type of int, because it's going to be returning a value of j. So you can see that j is integer, so it needs a return type of int. So over here, location of smallest, let's have some input parameters. The first input parameter is the array, and the second parameter is the s, and this third input parameter is the ending point. And you might be asking why I did this. And you can see over here that the starting point is going to be I, the ending point is going to be n minus 1, so it's always going to be checking at the end. So it's going to be looping through this whole array and trying to find the smallest, and when it finds the smallest from I, and then it's going to swap the value using the swap function, and that's how we're going to be implementing this selection sort algorithm. So if I'm going to create an I over here, I'm just going to create intermediary variables. One is going to be I is equal to s, so is, so I is going to be as the starting point, and then we're going to have j, which is going to equal to basically I, not s. So we're going to implement it, and we're going to say whatever I is, that's going to be when j, and I over here is the starting point. And then what we'll do here is that basically we're going to have our loop again. So while we're going to have I less than equal to e, which is the ending point. Now if a, and then we have a sub I, which is the first element, if that is less than a sub j, if we find some kind of thing that is greater, so a sub j is greater, so what we would say is j is equal to I. Just want to swap, right? We want to locate it, and then after that, what we want to do is basically increment it using I plus 1, right? So that's going to be incremented, and then we're going to return the value of j. And don't worry, I'm going to be explaining this through a graphical representation. So this is how it's done. So we have our three functions. We have a swap function, and we have a location of smallest function, and we also have a selection sort function. Let's create a display function to display the contents of the array. So it's going to be called display. It's going to have an integer array, and it's going to have the size of the array, which is n. And what you're going to do here is basically it's going to start from a 0, and how it's going to be implementing is basically while the I is less than n, and then we're going to be displaying the contents of the array by using a sub I, and we're going to have the double quotes over here, which is space, and just it's going to keep on listing them out, and then it's going to print an end line over here just to make the format a little more prettier. So right after that, what we'll do is basically have the array over here specified. Let's just create an array which is going to be called ARR, and it's going to have some random values. So it's going to have 102, 12. I'm just giving random values over here. It's just in random format. It needs to be sorted using my selection sort function. So I'm just going to pass this in, so you can see that this is random. And now what I'm going to do is basically calculate the size. How to calculate the size? One of the processes I'm going to use is basically the size of operator. Size of operator is going to pass in, and it's going to have the array, and then it's going to have the size of basically the integer variable. So basically you can see that this is the data type, and it's going to be 4. The array is basically the whole thing. So you can see 1, 2, 3, 4, 5, 6, 7, and 8, and 9. 9 multiplied by 4, which is basically 36. And now 36 will be basically divided by the integer, which is going to be 4. So 36 divided by 4 is going to give you the value, which is 9. So 9 is going to be the answer right here. So once this is the size, I'll just comment over here and say size equal to 9. What we want to do here is basically we want to implement our selection sort. But first of all, let's just display it. So let's just display, and we're just going to pass in the variable and the size. So it's just going to automatically display because it's a void function, and its purpose is to display it. And then right after that, let's just call our selection sort function, and it's going to ask for an array and also a size. And then after that, we'll just display our selection sorted array using array, and then we have size. So once I do this, I'll just execute and run it. So basically, let me go in my terminal screen. Over here, I'm going to write G++. I'm going to use the selection sort.cpp, and we know that by default it's going to be A. So I'm just going to run it, and I'm going to say and I'm going to say selection sort. So now it's compiled, and now let's run it. So selection sort. Now you can see over here we have some random stuff. What's going on? Okay, so something went wrong. Control T to break the code. Something went wrong in this code, and let's just check what it's wrong? What's wrong in this? So we have I less than n, and we have it's incrementing, so this is process is okay, n minus 1 is okay. There's some infinite loop that's been created using selection sort, array, and then size. And so let's just look over here. Okay, so I forgot to increment this I++. So just right here, I had to increment, and now it's going to be working. So basically, we're done that. And let's just run this code once again. Selection sort. And now let's call this, and look at that. We had this array which was unsorted, which is 102, 12, 193, 19, whatever, 32. And now what we did is passed in the selection sort, and it sorted the array for us in 11, 12, 39 in ascending order. Now ascending order is that, like, if you have the same value, it could be equal or it has to be greater. So just in case, if I have a value like 11 and 11, they're going to be in the same adjacent locations, and then after that it could be a bigger value. So that's sorted in selection sort. I really hope you enjoyed and you understood. So what I want to do is, one other thing is basically show you how the implementation is done. So suppose that the array is sorted like this in the memory. So we have some kind of indices. So we have like 5, and we have 4, and we have 3, and we have 7, and we have 9. So we want to sort this in ascending order. So what we can do by default with selection sort, it does is that it makes this I as the index of 0, and it will check for j. So my process here is like that location of smallest will be called, and you can see in my code, which is basically in here. So I'm just going to show you over here. What I see here is that the location of I is 0, and then while I is not less than n minus 1, the last element, what we do is we get the j and we put that in the location of smallest, passing a. We have the I variable, which is basically going to be 0, and n minus 1, which is the last element, and it's going to be in the location of smallest. So location of smallest is going to locate for the variable, which is going to be this smallest one, even I less than equal to e, if it's less than or equal to. So if it finds it, it's going to sort that as j, and it's going to return that value. So you can see what's happening is that it finds the smallest. So you see that the smallest here is 3. So j is going to be pointing here, and then it's going to be applying that sorting algorithm, which is going to swap this. So you can see over here that it's going to be swapping. So we have 3 over here, and then initially 5 is going to be over here. But what we want to see here is that in this text editor is that this is basically displaying. So we have the selection sort, and then once we go back into our selection sort algorithm, we have a swap function. Swap is going to get this value of I and the j that's returned from here, and it's going to swap it. So basically the simple swap algorithm, it's going to swap the both values, and then after that it's going to increment, and it's going to go to our next location. So you could see in the place over here, it's going to now it's not going to be pointing over here now anymore, and it's going to be pointing over here. And now this j is not going to be over here. So just want to indicate that this j will now going to be pointing somewhere else. So we have this I now incremented over here. So I is going to be incremented over here. Now this is going to be its base, and what we're going to be checking now, because this is now going to be sorted with 3. So now we're always basically over here. So now we're going to look for a value that is going to be smaller than 4. So basically, is there something smaller than 4? It's not. So that we just increment and we say I is going to be over here. Now it's 5. If there's something smaller, it's okay. So it's going to be checking all, and it's going to go throughout the loop until the whole array is sorted. So I hope you understood this concept of selection sort through this graphical implementation. Now we're going to go to our next sorting algorithm, and let's go towards it. Alright, so now let's look at another sorting algorithm. This is called the BubbleSort algorithm, and it's going to go as followed. So basically you have to include your input-output stream, and you're going to have to do your namespace standard, and let's just go simply write our boilerplate code. Okay, so this is BubbleSort is going to also deal with swapping. So we're going to have to include this swapping methodology, which is basically swap, and then we have an integer array, we have an x value, we have a y value, and basically when we go over here, we have actually a temporary, which is going to be assigned to the first value, and then we have the first value, which is a sub x, is going to be assigned to the a sub y value, and then the a sub y value will be equaling to the temp value. So this is how the swap works. And now let's have a bubble process. So the bubble process is a little bit different. How it's different is that from selection sort that we already covered, we actually went from the top, right? So we went from the top and then we went our way to the bottom. So in BubbleSort, we're going to go in the bottom to the top. So I'll just explain it. So first, just type along. So it's going to be B-U-B-B-L-E, bubble. And then what this process is going to do is it's going to do some specific process. It's going to get an array, and it's also going to get the size of the array. And we're going to go back to this a little later. So I just wrote the signature right now, and I'm going to go and talk about the void bubble process. So the BubbleSort actual functions. This is the actual BubbleSort function. And what we're going to do is basically it's going to have that same integer array, which is right here, and then we have the size n. So now over here, what we want to do is basically start from the portion what I was saying that the BubbleSort is going to be adopting. So the BubbleSort is going to say integer I is equal to 0, and what we need is while we have I is less than n minus 1. The last element, we're going to have bubble process, so BBLE, bubble, and it's going to have the array and the n value, which is n is going to be the size, a is going to be the array, and it's going to increment its way. So it's just going to go and increment. So in the bubble, what we're going to have is in here. Now we're going to open it, and we want to start. So the bubble process is going to be from the I. So it's going to start from the last element. So that's what I was talking about. N minus 1 is the last element, and it's going to go like while, and we have basically I greater than 0. So I greater than 0. And now inside of this is if we have a condition that if a sub I, now a sub I should be less than a sub I minus 1. Now this means that there's an a sub I if it's the top portion is greater. So what you want to do is that if a sub I is less than the a sub I minus 1, what you want to do is swap it. So we're going to swap it using this swap function that we already have. It's going to take it's going to take the I element, and it's going to take I minus 1. So that's how it's going to swap it. And we're going to have it generically having going minus minus because we're starting from n minus 1. It's going to go all the way to 0. So this process should work. So now after that, we should have our display function, and we're ready to go. So basically display over here, have an array, and we also have the size of the array, which is some kind of size. I would just call it as that. And inside of it, we need an input, so I would just say some kind of I is equal to 0 integer, and then we have the loop process, which is going to start from I less than n, and then it's going to go, so basically I is less than n, and you want to process it, so array, and then we have the ith value, and we're just going to keep on going like that until we reach our ending point. So which is console output over here. Yeah, and just to make it a little more similar to the previous one, I'll just change this to just n, because this one's matching here. So now let's create an array over here, and I'm just going to call it as integer array, and I'm just going to give some random elements to it. So let's just say this, and then something like that, this, and 33. Okay, this is just random stuff. Now I want to sort this, so I'm just going to first display it. So I'm going to display, I'm going to say array, and I also need my size data type. So actually my size variable. So I'm going to have size, and over here I'm going to say size of, and I'm going to have the array, and I'm going to say size of, and I'm going to have the int. It's going to give me the size. Now what I could do here is basically have the display function called, and then the sorted function. So it's called BubbleSort. So I'm just going to name it BubbleSort. I'm going to pass in my array. I'm going to pass in my size. I'm going to display once again. So I'm going to display array, and then I'm going to pass in the size. Now it's supposed to work. So let's just go to our G++ compiler over here. Let's just type BubbleSort, BBLSORT, and we say .cpp, and let's just name it something like -o BBLSORT, and there you go, compiled, and there you go, it ran. Whoa, what happened over here? I think we did the same exact mistake. So let's just go back over here and see where we went wrong. Okay, so we just forgot to increment on while loops. So remember to do this. This is really important. Okay, so I++ over here, so that it just loops out and it doesn't cause an infinite loop. So over here, and let's just go back over here to compile it, recompiling it, and running it again. You can see that my original array was 102, and then 293, and then 1939, and all of that. And then once we passed in our bubble sort, it actually sorted out some from 1138, 102, and all the way to the last element. So that was pretty cool, sorting an array in ascending order using bubble sort, selection sort, because the methodology was basically a little bit different. So I just want to show you how this is implemented in a graphical way. So the implementation of the bubble process is basically similar to what we did with selection sort, but in actually reverse order. We have this swap function that's going on, but we have this visualization that could help us understand how this process is working. So suppose we have some random values here. We have 3, we have 5, we have 1, we have 4, and we have, let's say, 3. Now, the bubble process is going to work like this. So let me just go over here, and now let's see. So it's going to start from the bottom, and it's going to compare these two values. Now it says that 3 and 4. Now what you mean that is basically bubbling, meaning its liquid portion is on the bottom, and liquid portion is basically heavier than the bubble. Bubble is lighter. Bubble makes it float on the top. So when you compare a liquid and a bubble, bubble is lighter, so bubble should be on the top. So this is exactly the same thing. They're talking about the weights. So 4 weight is heavier than 3 weight. So 4 should be on the bottom and 3 should be on the top. So this is one actual process. What's happening here is that the swap function will be called, and this is going to be changed to 3, and this is going to be changed to 4. And then after that, bubble will go up over here 1 step level. So it's going to go from here, now it's going to go over here. So now it's going to compare 3 and 1. So 3 and 1, actually what's different now? So you have over here is basically, you say 1 and 3, so actually it's okay. So 3 is heavier than 1, so 1, it's okay. So go again. Over here, 1 and 5, so 5 is heavier. So basically 5 will go on the bottom and 1 will go on the top. Now over here, now 1 and 3, so basically 3 is heavier, so 3 will go on the bottom right here, so just 3 is on the bottom right here, and then 1 will be on the top. So this is one actual bubble process, and you can see 1, 3, 5, 3, and 4. Right now, we basically did our one process here, and we sorted till this portion. There is more processes, and you'll need to do one more bubble process. So again, you're gonna have to go from the bottom, so you're gonna check like this. So basically, we're gonna start again, and we're gonna see the values once more. So forgive my writing. So 4, and then we have 3, and we have 5, then we have 3 again over here, and we have 1. So now 4 and 3, which is heavier? It's okay. Go up here, compare these two values. Now 3 and 5. So 3 and 5, actually 5 is heavier, so 5 will go on the bottom. So 5 is over here. Just cross this one out, and this portion will be having 3 now. Now 3 and 3. Well, actually it's the same equal, so it's going to be okay. So 1 and okay, so it's okay. So 1, 3, 3, 5, 4. Now one more process. So after one more process, so we're going to have one more process. So let me just erase all of this. Now we're gonna have even one more process, and now this should be our final bubble process. So let's just look at the values again over here, and then over here, and then over here, and then over here. So this is 1, and then this is 3, and now this is 3 as well, and now this is 5, and this is 4. So it's gonna start from the bottom, and you see that 5 and 4, well, 5 and 4, this is different, this is heavier, so the heavier portion should be on the bottom, and the lighter portion should be on the top. So 4 is going to be over here, and then 5 should be over here. So 5, 4, and then 3, 3, 1, 1, it's okay. So this is our exact sorted array, and this is how we're going to be sorting our array in BubbleSort. Slower, and it depends on the number of inputs. So it could vary and exponentially grow as the inputs increase. So that was bubble process. All right, so now let's jump into insertion sort. So this is pretty much different from the other two that we've included right now, which one was selection sort and the other was bubble sort. So I would just encourage to type along with me, and the explanation will be doing side by side. So let's just go and include this main, and then let's just go over here and then return the 0. Okay, now what's gonna happen here is that we're not gonna have a swap function like we did with the other ones. What we're gonna have is basically some differences. Now the differences is that we're gonna have this insertion sort function, and the insertion sort is gonna basically have an array. It's gonna have one more thing that is gonna be inside of it. So the first thing that's gonna have is gonna be the size. This is pretty much similar, and one thing here is that it's going to start from 1, not from 0 like others that do, because we're assuming something, and assuming is that the assumption is basically that some portion of the array is already sorted beforehand, and we just have to like insert elements into that sorted array, and that's how our process is going to be done. So we're going to go and we're going to have a while loop, so that I could tell you that it's going to go in a while loop. It's going to go to n, and it's going to say insert ith. This is going to be the function that's going to be called, and this function is going to take in an array, it's going to take in the size, it's going to take in the element, which is going to be the portion that I'm going to be talking about, and then this is going to keep on incrementing I++, right? Like in other languages, like I is equal to I plus 1, whatever it is. Man, I can't get the plus right. Okay, so just like that. So I++, whatever it is, like that. So now let's have the insert ith element. How do we do this insert ith thing? So let's go over here, and after this, let's just talk about the insert ith. So this is actually something that's also void, and it's gonna have the insert ith element. So just ith over here, and now inside of it, we're gonna have the array. We're gonna have the integer n size, we're gonna have the integer I size, which is specified over here. We're gonna have this key variable, intermediary variable that's gonna store our ith location, or basically the value of our I, and now it's gonna say int j, and this is j is gonna be the last element of that sorted array. So last element of that sorted array is gonna be I minus 1, because I is actually after the sorted array, and I minus 1 will be the last element. So we're gonna have a loop again, and we're gonna have two conditions for this case. We have j is greater than equal to 0, and we also have one more condition, that j should be actually greater than the key. So if j is greater than the key, we're just gonna keep on looping this. So not a j or whatever it is, a key. So a sub j. So let me just have this a and then a j over here, not just plain j. Okay, so a sub j should be greater, and then the j should be greater than equal to. So what's going to happen here is that a sub j plus 1. This is going to be implementing, and it's going to equal to j. And hold on, I'm just going to teach you this. Don't worry. So now we're going to have j is equal to j minus 1. Now it's just going to keep on decrementing, going to the top like a bubble sort. It's going to go up and up and up until you reach that less than equal to 0, or if a sub j is basically greater, or if it's less than, something like if it's less than, then it's going to just break out, less than the key. And naturally what's going to happen here is if this condition is false, we're going to have a sub j plus 1, where we're trying to implement, and we're going to put that key thing inside of it, that lost value. And now we just have this display function, which is going to be over here. Let's just have it over here. So void, let's have a display, and let's have an integer array, and then let's have the size of it, and then let's have something which is going to be the I. It's going to start from 0. It's going to go basically from while, and it's going to just check that I is less than n, and then it's going to go and say our console output is going to say ARR. Actually, it's not ARR, it's going to be A sub I, and it's going to be I, and then it's going to be that. Over here, there's going to be a comma right there, and then there's going to be an end line, semicolon right here, and actually not this, I don't want that, I just want a semicolon, and this is going to be incrementing, so I plus plus, and then we're going to have a end line over here. There you go. And let's just get some data from our previous sorting algorithm. So like a bubble sort, let's just get some of the data, just the array portion, not anything else. So just get this portion over here. Let's just copy this and just come here and just paste it. So I'm just gonna go here and we're just gonna paste it right here. So the only thing I'm gonna be changing here, everything is okay. I just wanna sort it using my function. So I'm just gonna call it with my insertion sort. So insertion sort is gonna be called. Okay, so the insertion sort should be over here. Let's see. Yeah, the insertion sort is right here. It's gonna go and it's gonna call this one insert ith. So it's gonna perform some operation, and then it's gonna go back plus plus. It's gonna keep on doing, and it's gonna keep on calling this insert ith so many times until the thing is sorted, and then after that we just display it. So let's just run this code. I'm gonna go over here my G++, and let's just clear this screen, and let's just compile. So basically G++ ins sort insertion sort.cpp, and then we can say -o flag, and then say ins sort. Okay, it should be working, compiling. Okay, so there's a warning over here in 25, no return statement in function returning non-void. 25, let's see, 25, where are you? 25 is over here, and there should be something over here. Insertion sort, it doesn't have a return type. Wow, should we have a void? So let's just have a void over here. Let's just go back here, and now let's just compile it, recompile it. And there you go. Now we have ins sort. So insertion sort, and if I run this, you're gonna have this sorted. So 102, 293, 1939, 1832, yo, 1138, 102, and 293, 311, and this is also sorted in ascending order. Now let's have the implementation. So this is basically an array, just a random sample, and we have 379, and somehow this is basically sorted from here. How did that happen? Just randomly. It just sorted beforehand. And now our I is going to be over here. So it's going to be after that sorted, and then the J is going to naturally be going to be over here. But remember I said that it's going to be I-1. So this is J, and the first process is going to happen. So if I go over here back in my code, so my code is over here, and if I see over here that this is going to be the process, insert ith. It has an array, it has the n size, it has the element I, and it says that key is equal to a sub I. So there's going to be a variable that's going to be stored, and J is equal to I-1, and it's going to say that J is greater than or equal to 0, and a sub J is greater than the key. So it should be working like that, and let's see if I could implement here. So we have a key variable, so let's just have a key over here. So key, K-E-Y, store that value inside of it, which is going to be something inside. So what's it going to be? It's going to be the value of I. It's going to be a sub I, so that's 4. So 4 is here. Now ignore that. Now what you're going to do is basically you're going to check the condition, and the condition is true. Why? Because a sub J is not, it's greater than or equal to 0. Actually, if I go back over here, where am I? Okay, so you could see that it's J is greater than or equal to 0. It's perfect. And then a sub J is greater than key. Now if I talk about the a sub J, now if I talk about that, let me just see it. A sub J is basically this 9 right now, and we have a key which is 4, so that a sub J is greater. So no offense, we're still working. Okay, so the thing is gonna still work. If I go back over here, we're gonna have a sub J plus 1 is equal to a sub J. So that means that we're gonna have something that we're gonna be implementing. So a sub J is gonna be over here. So we're gonna go over here. So this is gonna mean that J plus 1 is this portion, and it's gonna equal it. It's gonna assign this 9 over here. And what's gonna happen is that it's gonna go -1. So J is not gonna be here anymore, and now it's gonna go over here. Okay, so that's one process of that loop. So that's one process of it, and let's go again. So a sub J greater than this is greater, J is greater than or equal to 0, and a sub J is greater than the key, because the key is 4 and J is 7, so that's perfect. Now let's go back over here, and we see that a sub J plus 1 is equal to a sub J, and we have J minus 1, a process again. So whatever that value was, so we have 7 over here, that 7 is gonna be now over here, okay? So the J is gonna go up here now, and it's gonna remove it. You can see that the I is still over here in this location, and you can see that the 4 was removed. So we don't have that value anymore. That it just changed to 9. See over here, this is 9. And where does 9 come from? It came from here. So where the 7 came from? It came from here. So this is happening. So we have this lost value over here stored in our key. So that was the purpose of the key. Wow, nice key. So now what we're going to do is basically go over here, and we're going to see a sub J plus 1, and it's going to see this condition. Is J greater than or equal to 0? Well, that's true. If I look at that position over here, it's greater than or equal to 0, but it is equal to 0, so it's true. But the second condition is not true. Why? A sub J is greater than key, and actually, it's not greater. How is it not greater? it's less than, because it's 3, now this key is greater. So this just terminates that loop, and what's going to happen now is that the key is going to be sorted inside of this this portion over here, which is j plus 1. So that key value, which is 4, is going to be over here now. This 4 is going to be over here. 3, 4, 7, 9. Whoa, this is sorted, and now it's gonna move on, and this is I now, new position of I, and this is going to be a new process. So that's how it's going to be starting. If I look back over here, so you can see a sub j plus 1 is equal to key, and then the process starts again if you want to do it, and that's how basically we're going to sort it. Insert sort, it's going to increment its I value again, it's going to go in a new position, and then after that position, and then after that we have insert ith, and then the process starts again and again and again until the whole damn array is sorted, and then we get this ascending order of it. So I hope you understood this concept of insertion sort. Really, if you took this concept and overall like take a practice of it, I definitely know that you can do it. So next off, we're going to be diving into another algorithm. Let's dive into the merge sort algorithm. So let's just type along IOStream, namespace standard, main, and the return 0 semicolon. Okay, so let's create some functions here, and let's just explain it the way we do it. So first of all, let's just find our way for the merge sort. So we're gonna initially have a merge sort function. So how this is gonna work is basically we're gonna say void mrg sort, and we're gonna say we're gonna have an array inside of it, and we're gonna have the size of that. All right, so this is gonna have another function inside of it. It's gonna call another function. And what this process is called actually, this is called a wrapper function, and it's gonna pass into an auxiliary function. So this is a wrapper function. All right, so what we could say is this is merge sort, and it's going to have the array inside of it, it's going to have the size of that array, and it's also going to have one other additional parameter. So additional thing is that it's going to have the size, but before that it's going to have one other thing. It should have the index of the first element. So it's going to be the array, the index of the first element, and then the size of that, basically size minus 1. And this is how the merge sort is going to be. Over here, we're going to have that auxiliary function called. So on the top, we could just specify our auxiliary function. So auxiliary function. And what we could say over here is we would just have the same void mrg sort, and now the same input parameters. Well, we have an array, so we have this input array. We have basically the start value, and then we have the end value. Okay, these are basically the indexes, and we call this as the auxiliary function, or we also known as a, say, helper function. These are some of the names we could use. So let's have a base case to this. Now, yeah, I don't know what a merge sort is. Right now, we just basically drew out the thing over here. So we have this function and it calls to another function. Now the scenario here we have is basically a same array, and somehow it's sorted in sections. So you have a first part which is sorted, and the second part is sorted. And our job here is, don't think of this as just two arrays. This is one single array, and somehow we have this first part sorted and we have the second part sorted. And our job is to make this sorted in one whole. And how we could do this is the process of merge. So we're going to use merge sort algorithm to do this. So what we can do is we have to know in advance how the first part is sorted or the second part sorted, and we have to put a trust. We have to put faith in one process, and that famous process is called recursion. And now that's what we're going to be applying. So you're going to check, and the process is going to go like this. So we're going to have this first element 2, and we're going to check this third out, this part over here. So first of these two sub arrays, and I'm going to say 2 and 3. Which one is greater? I mean, which one is smaller? So basically 2 is smaller, so a 2 is going to be planted here, and then this is going to be incremented. So this array index is going to be incremented, so it's going to be +1, which is going to be 7 now, and this part is going to remain the same. Now 3 and 7 will be compared, and we could see that 3 is lower, so 3 is going to be placed in here, and now this is going to be incremented to 4. So you could see that 4 and 7 will be compared, and we have 4 over here, so 4 is going to be, and now this is going to be incremented to 5. So 5 and 7, and 5 is now going to be added. So 5 is going to be here. Now it's going to be 15 and 7, so 7 is going to be here, so 7 is going to be here. Now 11 and 15, you can see 11 is smaller, so 11 is going to be in here. So is going to be incremented to 19. So we have 15 and 19. So now we have 15 over here. So 15 is going to be over here. And then we have this compared to 15 is going to be incremented to plus plus. So we have 18 and 19. So what is it? 18. So now you can see over here, we assumed that this part is already full. Now what do we do? Well, now what we're going to do is basically this last part, we're just going to append to the end. So that's our process here. What we're going to do is append these 19 and 21 to the end. How we're going to do this, and you can see by this is just sorted in our ascending order fashion, and that's what we required. And how do we do this? And you would ask me, now if it was sorted like this, why not just put like a pre-existing sorting algorithm, like a merge, like something like insertion sort or selection sort? Well, that process is going to take longer, and this process is fairly shorter. That's the crux of merge sort, and that's why it makes it faster. It's much more faster as compared to any of the sorting algorithms we've discussed so far. So now let's go back into our code, and now let's start typing along. So first of all, let's have this merge sort, and inside of this we have an array, we have this int s, we have this int e, we have a helper function. Out in the condition we have a base case. Now we have this s greater than equal to e. This is some case that's not true. It can never be true. In this case it would just return. So this is our base case. And that after that, you could say that this is not going to be true, because start is never going to be greater than or equal to e. That means that it's just illogical. Always you have a start which is less than equal to e, and I'm talking about the indices over here and not the value. So you have a start, like for instance we have a start here and we have an end over here. Obviously these are indices, and indices are start from 0 all the way to n, right? Indices start from n minus 1. It never does it the other way around. So that's just illogical. And now we're going to have the implementation array. We're going to find the midpoint value of that array. So this is our function here. So what we have to do here is basically let me just put these plots back. Okay, so our process here is we have to find the midpoint value, which is right here. So you can see over here, if I observe here, that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. And if I go from here, like the start value was 0 index, and the last value which is 9, and if I divide this by 2, I'm going to get a 4.5, right? And I'm going to get the integer division of it. So I'm just going to get the 4 part. The decimal part is just going to be excluded. So we can have 0, 1, 2, 3, 4. This is our 4th index. So this is our 4th index right here. And what I'm going to do here is I'm going to place that value. So basically this is our 4 index, and we're going to split this here. And this is now, you could see that this is our mid m. I would say this is our m, and the stuff that is before is going to be the things. So 0, 1, 2, 3 is going to be 4, and then after this is 0, 1, 2, 3, 4. So this is 5 over here, and this is 4, and this is our midpoint. Now suppose if we added something like had an odd number, then we'd have even cases here, but in this case we don't have. But this still is our process. This is how it's going to be implemented. Go back here, and we have this mid, and this is going to be a simple function. What we're going to do, it's going to be s plus e. Now this is going to be the start index and the last index, and we divide it by 2, just like we discussed. And I know that's pretty really simple, because this is n minus 1. I told you over here that that's the last element. E is indicating the last element, and it's just going to divide it by 2, which is gave a 4.5. It's going to be 4 because it's an integer division. Okay, so now let's have that merge sort calling using recursion. That's what I was talking about. So it's going to start from A. This is our starting point. Now, careful here that this is an array. The starting point is S, but the end point is now M. Why? Because now we're going to try to split into 2 subarrays with sorted processes. So merge sort we're going to call again, and the second time we're going to have A array. It's going to start from M, and it's going to go all the way to the end. So it's going to be not m but m plus 1, because now we're going to have this process additional. So over here we have this portion we want sorted, and we want this portion sorted. So we're just discussing right now this portion, not this thing over here, not this right now. We're just looking at the top. So I hope you got the point over here, that we wanted this sorted in ascending wise over here and ascending wise here. Okay. So back over here, we have this m plus 1, and now we call one more function, and that function is basically the combine function. And the combine function is going to be pretty much something like this. We have an A array, we have the S, which is the start, we have the middle value, which is the M, which is the last value, which is E, and this combine will be defined over here somewhere. So let's have this combine defined. So now what we're going to do is basically we're going to say void combine, and if I have that specified here, I would say int A, and then we have this array right here. We have an int S starting value, we have an int M, which is the middle value, forget that, right? And then I got the last element, which is end. And what we could do here is that we want a temporary buffer, and I'll tell you why. Just hold on a moment. So let's just create a buffer over here, and what it's going to do is basically going to get some value from the heap, or it's going to get some so it's going to be it's going to be a array from the heap that we're going to get, and basically this is going to be representing for the total size of the merged array, what we're talking about. And what we're going to do here is that we're going to have a k is equal to s, and we're going to say while. So while is over here, and we can say k less than equal to e. And what we do here is buffer, and we say buffer sub k is equal to a sub k, and we can say k is equal to k plus 1. Now what do you mean by this? Now I'll tell you what this means. The thing is that we're creating a temporary buffer that we're allocating from the heap, and then we're going to deallocate it using the delete keyword. But before that, we're using it because we don't want to reassign it in that existing array. So we want it basically stored, and then we want something over here. So I would just say this portion here, B-U-F-F-E-R. This is the buffer, this portion, and this whole thing. I'm talking about the whole thing. So this is buffer, and this is going to be our output array. So this is going to be the sorted array. We're doing it in two separate things because if we sort it in just one single array, it's going to cause complexities, much more complexities, as just copying the elements. So suppose we have this array. So just ignore this part because it's not sorted right now. And we just created a duplicate array that had all the values. So it started from k and it went, so it said 0 all the way to the value, last one. So if I go back here, you could see that k started with a starting value, and it was less than equal to n value, and it just said buffer sub k is equal to buffer sub k. So a sub k, whatever the values were, it's going to sort in the buffer. So it just initialized all of them and just k plus 1 all the way to the end. So just copied them, made a duplicate, right? So now after that, we could do is we're going to have something specified here right after this. So once it's copied, we have I is equal to S. Now we're going to have one thing over here, which is J, and we're going to say M plus 1. Now I'll tell you why we did this. And we also have, which is K, and we set that as S. I is equal to S. Go back here, and we have this I, and it's going to be over here, which is the starting value. Just give me another color over here. I'll just get a little darker. Okay, so I is over here, which is right here. And the second one, what we have is this mid. We know that. Okay, so other one we have is J is equal to M plus 1. So if I go back here, we have this J is this over here. And we know that this is endpoint right here, E. So you can see that this I has to go increment all the way to the M. This is its last element. And this J has to increment all the way to the end portion here. So that's how we're gonna compare the values, like 2 and 3, which one is smaller, 2, plant it here, go increment 2 to plus 7, and then we're gonna say 7 and 3, what is smaller, 3 is smaller, plant it here, and then put the rest. So that's the process what I'm trying to implement through code. I have to map this out. So that's why I'm using this diagram. That's what we're doing. So we're gonna have int k is equal to s while, let's have this while loop, and this is how this process is gonna go. I, which is that value what I told you, this over here, I is less than equal to m, and j is less than or equal to e, some process is going to go on. So if I less than or equal to m, and we have j less than or equal to e, we want some process going on. So if that buffer buffer is equal to I, and then we have less than or equal to buffer sub j, if this process is done, so if a buffer sub I is less than or equal to buffer sub k, so what we're going to do is a sub k, that process what I was talking about, that if it's less or equal, then just copy it inside of that k, the array which is over here. We want to sort it out, so we're just going to copy here through buffer, so it's a buffer sub I. So in the case if it's less, right? If it's less or equal, and then we just increment I is equal to I plus 1. Just what we did over there. Just what we did over there. So if that's not the case, we'll just have an else, and we're going to put something in here. So let me just put over here. The case here is that a sub k is going to be over here, and it's going to equal to buffer. So it's going to be buffer, and then it's going to have sub j over here. So we're going to have this j in here, which is a sub k, because if it's not the case, it's going to be less, right? So meaning if it's less, but if it's greater, then the j is going to be there, and then obviously we're going to have j being incremented instead of the I being incremented. So we have that, and we have k is equal to k plus 1. Let me just have that. There you go. And now we have the condition here. So this is this case over here. This is a while loop, and we have another while after this condition. Now I'll tell you the reason why behind this. So we have this while loop, and after this we have 2 while loops additionally. I'll tell you the reason why we need those 2. The thing is that if we compare these 2, like suppose we had this 2 and we had this 3, we compared it, that 2 was less, and then we incremented it, we're just doing plus plus that we did. But the case when we came here, this 19 and 21, how did these come? This array just got full. All of this was full, remember, this portion. But then we just appended these last 2 inside of this. How do we do that automatic process? That automatic process is going to be done through 2 while loops we're going to be including. And that condition is like if I is less than or equal to m, or if j is less than or equal to e. Now this is the 2 conditions, and look at this carefully. So while we say I is less than or equal to m, so if this condition is like still there, like it's true, like it broke out, so the process here is that these 2 would never become false together. It was always going to be one of them and not the other, right? So if that case, like j is less than or equal to e, that came, and then after that we still have I is less than or equal to m. What we could do here is that a sub k, and this is the same scenario what we did with the example. A sub k is equal to, we're going to say buffer, so we got the thing from buffer, and we said that as j. And what we do is basically, actually we're going to have that set with I because it's I over here, and we're going to set that with I, and then we're going to do is we're going to increment I is equal to I plus 1, and we're going to increment the k is equal to k plus 1. And if the other case is there, like while j less than or equal to e, we're going to have a sub k is equal to buffer, and we're going to have that as j sub, there you go, and we have j is equal to j plus 1, and we have k is equal to k plus 1. It's just going to increment the k value, and you already know where k is starting. This is k right here, so this portion is k, and it's just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way when it's done. So it just keeps on incrementing. You can see that j is over here, I is over there, and that's the process going behind of it. And then once we're done with it, we don't want this extra memory, we just delete it. So we just delete our buffer, and using this delete syntax is basically we're going to deallocate it from the memory, and that's it. Now let's just have this additional function that we need is basically, I think so, it's a print. So, oh, I forgot my main logic here, int main. So this is main. Maybe I left it up on the top. Yep, that's a common mistake. Okay, so just delete that portion here. And let's just have a display function at the bottom here. So at the bottom value right here, let's have a display function. So it's going to be called void. We're going to have a display. And what we're doing is basically having an array, just like the small other ones. So have the size n, and we're gonna have something which is gonna be implementing, like we have temporary, and we're gonna have that associated with a sub. What am I doing? It's not actually that. It's I is equal to 0. My bad. So we're gonna have while I is less than n, and then we could say console output the array value, array sub I, and put that comma here, and then we have it just keep on incrementing plus plus, and yeah, console output here. There you go. And now what we do is basically run the code here. So get a random array again. So let me just get this array, which is right here, copy, and just paste it here. And let's just change up the thing over here, which is insertion or sort. We're gonna have MRG sort, merge sort. So let's go back to our G++ compiler, G++ mrg sort.cpp -o mrg sort, and it compiled mrg sort. There you go, voila, 110, and then 102, whatever, 293, and then all of that, and sort it in ascending order. So that was it with merge sort, and this is much more faster as compared to any of the sorting algorithms we've done so far. So even selection sort, bubble sort, insertion sort, even the problem that we did in the beginning, because those were of time complexity O of n squared, O of n squared, O of n squared, O of n squared. But this merge sort is somehow faster because it's doing the time complexity in O n log of n. So O, and then we have n, and then we have log, and then we have that n inside of it. And this is much more faster as compared to any of the other sorting algorithms. Now if you get like a set of arrays from a text file that I could be doing in my other videos, so stay tuned for my next upcoming videos in my channel, you're going to be seeing that we're going to have text files, and we're going to be looking and comparing how fast is this compared to other sorting algorithms. Because if we have these O of n squared sorting algorithms, these are going to take much more time. As the input value increases, it's going to exponentially grow. But as compared to merge sort, it's just gonna be fast as lightning because it's in O n log of n, whatever complexity. So hope you enjoyed this video, hope you liked it, and please make sure to visit my channel, which is called Coding Cleverly, where I have so much content of C++, and I've done data structures and algorithms, I have done object-oriented programming, and I've done the basics, beginner level procedural programming, and my goal is to complete data structures, and then after that advance to other project-based videos as well as new languages and technologies. So make sure to subscribe to that channel. And yes, thank you so much for watching. I really appreciate the support. So thank you so much, and thank you FreeCodeCamp for putting my video on their channel. Really appreciate it.